core components of our self-assembly system are the environment, water, methylated spirits and oil, the structured particles, hydrophobic sand, the driving force, gravity, and the binding force is hydrophobicity. Here is a demonstration of how the hydrophobic sand repels the water and doesn't allow the water to seep in, forcing it to sit on the surface. The sand mound retains its shape even when submerged in the water and stays dry once removed from the water. The hydrophobic properties arise from the fact that the coating spray is non-polar whilst water is polar. The opposing polarities repel each other, which is the cause of the aggregation of the sand in the water. Compared to the previous shot, the sand clumps here are smaller clumps due to the use of a funnel to drop the sand. The shape of the sand in the water is controlled by factors such as drop rate, volume and speed. This is similar to the mechanism behind liquid 3D printing and injection molding. Here, the hydrophobic properties of the sand are not observed when submerged in methylated spirits, which is an alcohol mix. This is due to the chains of non-polar bonds in the alcohol, which attract the non-polar sand, causing it to disperse and the environment to become murky. Once the sand is removed from the non-polar environment, it is no longer dry, unlike when it was removed from the water. One such application for self-assembling hydrophobic sand is for the cleanup of oil spills in the ocean. Although not clearly seen, the surface oil layer is captured by the falling sand and can thus be collected and removed from its environment.